Here at Physics Flies, we pride ourselves on being the premier travel company in the Northern Hemisphere. We focus on the Aurora Borealis, an aurora created by the solar winds given off by our Sun. The solar wind is an outflow of low-density plasma from the corona of the Sun. These particles that make up solar winds are electrons, protons, and alpha particles, traveling at a speed of 400 kilometers per second. These particles are influenced heavily by the Sun's magnetic field, but some particles manage to escape through the Sun's coronal holes, usually found at the Sun's poles. Sunspot activity has a profound effect on the Sun's ability to eject solar winds. The activity itself has an 11-year cycle, and the prevalence of these sunspots causes coronal mass ejections and other releases. The Earth's magnetosphere protects the Earth from magnetic interference. However, sometimes small waves of solar winds are able to penetrate the magnetosphere, generally at the Earth's polar cusps. This creates auroras due to the solar wind having a unique interaction with the different molecules in our atmosphere, like the Aurora Borealis you see here. Of course, we know that the Sun is just a regular star in the Milky Way galaxy, with a multitude of planetary satellites orbiting it. Past astronomers have looked to the sky and wondered how it all works, attempting to decipher the layout of the universe and our place in it.
Our whole universe was in a hot, dense state that nearly 14 billion years ago expansion started. Wait, the Earth began to cool, the Autotrophs began to drool, Neanderthals developed tools, we
Enough
built a
about
wall.
some cold words aimed at an uneducated science demographic. I'm here to talk about hard science. The general theory of relativity was published by Albert Einstein in 1915 and outlined that gravity was not a force but an effect of a warped spacetime. Depending on the size of a mass, that object could warp the fabric of spacetime, creating gravity wells that would cause other objects to orbit it. Isaac Newton's earlier work defined gravity as two masses' attraction of each other. The theory also predicts that light rays curve around large objects due to warped spacetime. This effect allows astronomers to study other objects obstructed by things in front of them, and allows for the calculation of distances over the universe. Additionally, it proves that time will run slower near larger objects such as the planets. This effect has been explored in the popular science fiction movie Interstellar. The relative effects of the gravitational pull on the planet and its orbital object, the massive black hole Gargantua, causes time to run far slower on the surface of the planet, and thus the astronaut in the orbiter aged 27 years upon returning. The principle of general relativity outlined the basis for an expanding universe. However, Einstein always believed that the universe was static and already whole. Alexander Friedmann, a mathematician from Russia, came up with two assumptions to tackle the static universe conundrum. The universe appears identical whichever direction you look, and this is true wherever your viewpoint lies. In 1924, Edwin Hubble observed individual stars in the Andromeda Galaxy. More specifically, a Cepheid variable, which pulsates. Pulsation allowed Hubble to calculate the distance from Earth, which was over 800,000 light-years away. By studying the redshift of these galaxies, Hubble concluded that Andromeda was moving away from Earth. He applied this formula to all galaxies that he's found. All galaxies were redshifted, proving that Friedmann was correct and the universe was indeed expanding. So that's just a glimpse of what knowledge is on offer with Physics Flies. We hope you decide to travel.